Hello everybody, this is the Fusion 360 CAM tutorial for the TCOSE number 8 part. Okay, so you should have already modeled the part. We're going to open our part in the data panel. Now this is going to be probably the most complicated part we do in the class from a setup standpoint. There isn't a great number of features, but the part is needs to be machined on more or less 6 sides. There are different ways to approach this part depending on what commands you're going to use and what type of equipment you have. This type of part could be a decent candidate for a 4th axis or 5th axis machine, but it's definitely machinable on a 3-axis machine. We just need to reposition the workpiece for each operation, and we are going to be using all 2D commands. There are 3D, if we were to use 3D commands to cut this surface, it would completely change the approach to cutting the part. But the scope of the class is 2D, so we're going to try to stick to the 2D commands. This is another example of a part where it's advantageous to model stock because we most likely need to do a few operations with the part still connected to the stock as a way to hold it. You could cut this as a block and square everything up, but especially this radius here, to cut that with a 2-axis move, it'd be helpful to have some material to hang on to in the vise to at least cut that operation. The rest of the part is blocky and bulky, so it can be clamped quite easily. So we're going to start off with defining our stock. And you should have done this in a couple other parts by now. We're going to start off with a sketch. And we'll place that sketch on one of the faces of the part. And then we'll draw a rectangle around our part. Now if I were to inspect our part, it is 20 millimeters in one axis, 20 millimeter, we have a 10 millimeter radius plus 14. So that's 24 millimeters. That's pretty close to an inch, which is 25.4 conversion. So I think what we'll try to do is design this around a 1-inch square piece of material. So as I usually do, let's set up our constraints first. If we're going to have a square, let's set up the 2 constraints of 2 sides to be equal. And we're going to dimension, and then we're going to dimension one of our sides. And we're going to make that 25.4 or 1 inch. Yeah, on prior projects I've centered it with a line. Now on this part we kind of have an asymmetric shape. It's symmetrical along one axis but not the other. So what we'll do is we'll do some constructive geometry. We'll pick on the center or midpoint of the bottom of our part and take that straight up to the midpoint of the arc. And we'll take that line and we're going to make it construction geometry. Now we will take and draw a line from corner to corner on our square. And we will also convert that line to be construction geometry. Okay, so we should be able to constrain the midpoints of those 2 lines, which will give us an equidistance of leftover stock on the respective sides. Okay, so we should have a 1-inch square centered around the width of the part, not the center of the circle, but the width of the part. Okay, so now we're going to say finish sketch. Okay, so we should have our sketch here. We're going to look at it a 3D view, and we're going to extrude this shape to about 2 millimeters beyond the end, so we have material on the end, and then we're going to extrude the opposite direction about an inch, so we have something to hang on to. So we will do extrude. We're going to select all the volumes within the box. And we're going to change it from one-sided to two-sided. And on the arrow that's pointing this way, we'll put 25.4, which gives us 1 inch. And then we're going to go in the opposite direction. We're going to go a distance to object. We're going to select this plane, and then we're going to offset an additional 1 millimeter. Okay, now it changed the default extrusion to a cut because it intersected an existing solid, and we'll simply change that to new body, and select OK. Now, as we've done before, we're going to go to our bodies, and we have our part model. I'm going to go ahead and name it 08. So that's our part model, and then the body 3 that was just created is going to become stock. Let's right click on the stock and change its opacity to 50%. Okay, so this will be the stock we start with, complete our machining. So we have about an inch that we can clamp on. We'll probably clamp on about 3/4 of an inch for our first operation. Alright, so our first operation will be the part standing up on end like this in a vise. To help you visualize how this part would be held in a vise, here's an image showing how this would be clamped in the vise for this operation. And we will machine this profile, machine part of the bore, and machine this set of holes. Once that's established, we will rotate the part so that it is in the vise like so. Here's an image to help you with visualization of the part for this operation in a vise. One important thing to note is that at this point in reality the part is machined to size, but the stock sticking out the end will be still at the stock size. So you're actually clamping on the finished machined edges, and also the convex side of the shape is facing down. So it'd be important to support the radius at its crown with a parallel, with the right side hanging off the edge of the vise, so that we can machine these faces, these holes here, and cut off the extra stock to this face. The following operation will be to stand this back up on end. To help you visualize this operation, here is an image of the part mounted in the vise. At this point, the exterior of the part is more or less cut down to net size, except for one feature being added. So you'll no longer need the model of the stock for the subsequent operations. The following operation will be to stand this back up on end to cut the second half of the bore and the 4 holes on the opposite side of the part. And then our last operation will be to lay it down like this. And here is one last snapshot of the part in a vise to help you with visualization of the last setup. And we'll machine this little counter bore here. The hole should be already established from our drilling all the way through the part from this side. Okay, so that's the plan. Okay, so now let's go over to the manufacturing workspace and let's start machining this, make it happen. Okay, so our first initial setup, let's orientate the part like this. Okay, so the end is going to be pointing up with our extra stock on the below that's going to be holding our part. So our first setup, we need to go through and tell it that its stock is the model that we set up here. So we go over to our setup and we tell it the model by selecting on model here, and we select on our part -8. So that tells it that our model that's the part itself. And now we're going to go to the stock tab, and likewise we're going to change the mode to from solid, and we're going to select the body for the stock to define the stock for this program. We return to the setup tab and we're going to set our machining orientation. So we're going to go from model orientation to select Z-axis plane and X-axis. We select the axis that's going to be normal to Z in this operation. It should be this face here. And then we select an edge to define what our X-axis is. So we want our X-axis here. And it's orientated the X-axis with the line we selected, but it's facing the wrong direction. So we need to check this box that says flip X-axis, and it flips over. Now let's place our origin. Our origin, we're going to use a stock box point, and for the purposes of this, we are going to put it in the back left corner. So you should have your origin placed as shown. If not, you need to play with these parameters, because if you modeled your part in a different orientation, your arrows may not start off in the correct place. And now we need to go to the post-processor tab, and this is part 8, so 08 in our first operation. We'll call this operation 1 with work coordinate system 1. Select OK. Now I'm going to rename what I have as setup 3 as setup 1. Just make sure that's in sequence. Let's go ahead and make our next setup. Our next setup we want to be like this. We want the material hanging off the right side of the vise, and we still have our stock shown here. Now we want to define our stock based off the model here so that it knows that this material is out here to remove. But we want to base our origin off machined faces. So we've already, at this stage, will have machined the part down to its profile. So what you see here is not really reflective of what we have. Everything to the left of this is going to be already machined to some degree. So let's create our setup 2, and we need to go through and say what our model is, which is part 08. And we're going to go to the stock tab, and we're going to change the mode to from solid and select the stock, just like we did last time. Now we're going to go back to setup, but we're going to hide the stock before we go any farther. the stock model. We have the stock setup, which is based off that model, but we don't need to physically see the body itself. We're going to change our model orientation to select Z-axis and X. So we're going to select this face is our reference for Z, and then something going along the X-axis is our X reference. Now in my case, the arrow flipped to the correct orientation, but if it doesn't, you can always click this box that flips the orientation. Now our origin is going to be based off a model box point. Reason being, we've already machined all this, so now we don't want to base any of our zeros off stock. We want to base it off accurate machined faces. So let's pick this back left corner as our origin. And we're going to go over to the post process, and we're going to set this as 08 02 operation 2 with a work coordinate system of 1. Let's select OK. And again, let's make sure our names are in sequence. Fusion auto numbers them, and I had already done some programming in this file and deleted the programs for demonstration purposes. So mine aren't starting out with sequencing as 1. Okay, so that's setup 2. Now let's go to setup 3. I'm going to show the stock just so I know which side it is. It actually will have been machined away, but I want to be able to visualize how I'm rotating the part. So the one end that hasn't been machined on to make these holes is the side that we just trimmed the stock off in setup 2. So setup 3 is going to have us facing up in this orientation, and then we can hide the stock. We're going to go and create another setup, and now the stock will be based off of the model because that's what material is left. We're going to go to the stock tab. No additional stock. Now it's still going to show material where to make it a rectangular volume so you can select on box points, but it's not going to treat it like there's material to remove there necessarily. So no additional stock, and then we're going to go back to the setup tab, and at this point we're going to set our origin again. So we're going to use a model box point, and we're going to select this back left corner, and we need to set our orientation by selecting Z-axis plane and X-axis. So our Z-axis plane is here, and our X-axis will be this edge. And then it looks like I've lost my box point, so we'll do that again. It's going to be up on this corner, and I need to flip the X-axis. And no, I want it on this corner here. Alright, so you should have this third operation with the orientation as shown. Then we're going to go over to post-process, and we're going to call this 0803 operation 3 work coordinate system 1. Hit OK, and I'll make sure this is called setup 3. There we go. And now to set up the final operation, which is really just to cut the counter bore we see around this hole. So we're going to go new setup, we're going to go to stock, we're going to say no additional stock, and then we're going to pick a model box point. Of this back left corner on the bottom. The reason I'm doing that is it's actually square there and it's difficult to indicate it on this top edge because it's radius. Now my model orientation is how you'd want it to be. X going right and Y going away. If it's not for you, you're not going to be able to use model orientation. You'll have to switch this to select Z-axis plane and an X-axis. And you can select on pretty much for a plane, you could select on one of the origin planes. So there's these XY planes that are by default hidden. You can show them and you select on those orange planes and the axes to set your origin orientation. Okay, so then we're going to go to post-process and we're going to call this 0804 with program comment of operation 4, and it's going to use work coordinate system 1 again. Select OK, and again make sure that your operations are ordered in a logical sequence. Okay, we're in a good spot here to start machining. So let's go back to setup 1 and we're going to do them in order. Orientate your setup so that your X-axis, your Y-axis, and Z-axis are pointing like they would be on the machine. And make sure you have setup 1 selected. And our first operation is going to do a facing operation on the end to take that material off. There's about 1 millimeter of extra material with saw cuts. So we're going to use this face command. Select face, and then we'll go to the TCOSE library, and we're going to select tool number 2 for the 1/2 inch flat end mill, and then select OK. Okay. We have a lot of material sticking out of the bottom of this thing. This thing's hanging out pretty far. So we want to be a little bit slower on our feed rate because we don't have as much rigidity. Let's go 25 inches a minute on all our feed rates except for the ramp. Actually, let's go 25 on all of these. Now, a face mill always ramps in from off the workpiece where there's just air. So we don't really have a true ramp or plunge. It's really a lead in. So we'll just set those all at the same. And we're going to go to geometry. Now the geometry is going to default to being defined by the stock, which was that stock model we made. That's fine. We'll leave that as it is. So there's nothing really to select. Go to heights, and our default at starting at stock top, and our feed height at top height, and the top is our stock, and the bottom is going to be the top of the model. That's what we're going to machine down to. So it's taking 1 millimeter off, and so what represents top is the cyan line represents the top of the stock we're just going to start machining off, and the blue plane represents the top of the model, which is the bottom of our cut. And as you can see, it's at negative 0.393, which is a decimal equivalent in inch for 1 millimeter. Okay, we're using a 1/2 inch end mill. It can definitely handle 1 millimeter all in one shot. And one reason we're using that cutter is when this is saw cut, this could easily be longer, and that end mill will be able to cut off even 3, 4, even 5 millimeters without much trouble. So we're going to go to passes, and our maximum step over is going to be 80% of the diameter of the cutter. So for a 1/2 inch end mill, that works out to 0.4 or 400 thousandths. Okay, most of these we can leave at default. Now, you can offset for extra stock. We do want a pass extension. Our pass extension is going to represent extending off the workpiece to make sure our cutter is off the workpiece when it plunges. So let's put that at slightly bigger than half the diameter of the cutter, which is 1/4 inch, and so we'll put in 0.3. We want it to cut both ways. This from other side switches the direction that it starts its cut. We'll determine that after we preview it and see what options are better. Now, multiple depths, we do want to do a maximum step down, and we're going to set that at 0.06, and we want that from both sides, and we want to do a finishing step, and the finishing feed rate can be the same, that's fine. And our finishing step down, let's set that at 0.02, so we're just skimming some material off to give it a nice finish, and we'll use these even step downs. We're not going to leave any stock, and we're going to go to the linking tab. Leave all these at default. I don't want a vertical lead in though, so alright, and we select OK. Okay, so we're machining from right to left. I actually want to have this machine forward to backwards instead of right to left. This is a tall part clamped in a vise. It'll have more support if we're cutting against the jaws of the part and starting our first cut against the fixed jaw. So in order to change that orientation, we go back to Edit, and we go back to the Passes tab, and we're going to change the pass direction to be 90 degrees. And that'll change the direction the toolpath goes. Now it looks like our initial plunge is going to come in where the fixed jaw of the vise is and come towards the operator. We want to reverse that. So we're going to right click on this again, go Edit, and we're going to select from the other side. We select OK, and now we're plunging near the operator, feeding into the workpiece, making that first heavy cut push against the fixed jaw of the vise and not the movable version side of the vise jaw. So make sure you've done that, and you may have to click different parameters because it depends on what order you made your geometry at what this defaults at. Alright, so we're done with the facing operation. Now let's move on to cutting this big hole here. Now we want to cut as much of this hole as we can. It's a little deep, so we're not going to cut it all from one side. I've looked at the drawings and they've dimensioned everything with a tolerance of being line to line. So the piston that goes in this is dimensioned at the same diameter as the hole. In reality, we need the hole slightly bigger than the piston or it won't slide. We're going to cut halfway through this from one side, halfway from the other side. That will probably result in a small amount of mismatch in the center of the bore. What we're going to do is, if we were to make this, we're going to go back in with a hand reamer and ream this bore slightly larger than the diameter on the print, and that will also take out any variation in finish inside the bore. So, that said, we will use a 1/4 inch end mill. We're going to do a 2D contour, and we're going to select, we're going to go to the TCOSE library. We're going to select the 1/4 inch flat end mill, tool number 4, and select OK. .4,000 RPM is fine. I guess 15 inches a minute is fine. So let's change that to 16 and 16, 16, 8 and 8. We're going to move on to geometry, and we can select the top or the bottom of the hole, but then we need to give it limits. So I'm going to select the top of the hole. I want to make sure the arrow is inside the part. We're going to go to the heights tab. Okay, we're going to change the retract height from stock to model top. And then we're going to change the top height to go from model top as well. So that lowers the beginning of our cut will be at this cyan. And the bottom of our cut is not going to be the selected contour. We're going to go from model top, and then we're going to put in a value of how far we're going to go. Now I believe our part overall length is 20, according to our drawing, is 24 millimeters. So we're going to go 25 millimeters, which what will result, or negative 25 millimeters. And what that will result in is we'll overshoot by about a millimeter, and then when we cut in from the opposite side, we'll overshoot by about a millimeter, and hopefully that will help blend any mismatch we have from setup and from cutter deflection. So we will be cutting from the cyan plane down to the dark blue plane. We're going to go to the next tab. We'll leave these at default. We're going to move down to the horizontal radius. That looks fine at the moment. Our linear lead in, yeah, that looks fine. We're not going to do a vertical lead in, we don't need that. Looks like I skipped over the passes tab, so I did this a little bit out of order. We'll come back to passes. We're going to do 4/10 tolerance, we're going to do left, and we're going to have wear compensation. We're going to skip on down to roughing passes and select that we are going to do roughing passes. That opens up the finishing step over, which we'll set at 10 thousandths. We'll come back down for a maximum step over for a 1/4 inch end mill is going to be 0.2. Smoothing deviation of 4 thousandths is fine. And we'll try to see if we can get away with one side step over, rough step over. Okay, we definitely want to do multiple depths. Our maximum step down with our 1/4 inch end mill is going to be 0.04, 40 thousandths. We're going to do one finishing step down just for basically a spring pass. And we're going to do that at 0.01 from the bottom. And on this particular part, I don't think we can get away with finishing it just at the bottom. It's a pretty deep bore. We want to make sure we rake all the chips out of here. So we're not going to select the finish at only final depth. We are going to rough the final, and we're going to use even step downs. The rest of these are irrelevant. We are going to check the stock to leave box. Remember I said earlier we want to ream this, so we're going to put 0 on our axial, but on our radial stock we want to leave, let's see, let's leave 2 thousandths, and that's per side, and so that'll leave 2 thousandths for our reamer to come in and ream, hand ream this out. We're going to check the smoothing deviation at 4/10. Now we've already filled out everything on the linking tab, so I'm going to go ahead and hit OK. And we process our part. So the cutter is close enough in diameter to the bore, I don't believe we'll be left with any extra material in the center. Okay. Now let's do the last two operations that finish off setup 1. Okay, now we're ready to drill the M2 holes. So we're going to go to drilling cycle, and we're going to select the TCOSE library, and we're going to select number 9, which is the tap drill for an M2 threaded hole, and select OK. For your design, it should work. And I set mine up with 6,000 RPM with 8 inches a minute and roughly 40 inches a minute for retract. I'm going to go to geometry, and I'm going to select one of my M2 holes, and then I'm going to select same diameter, and it should select the other 4 holes that we're going to make. Now we're going to go to geometry, and we're going to change these to model top because our stock has already been machined down. Our hole is going to start at the hole top, and we're going to go to the hole bottom. And we want to have our drill point breakthrough. Now I modeled my holes at around 9 millimeters deep plus the drill tip. The drawing calls for 8 millimeters of thread. So we're going to go an additional equivalent of additional 2 millimeters in depth for the drilled portion of it. Now this seems extremely long for a fastener. Had I thought about this earlier, typically you don't gain any strength beyond 2.5 diameters of the thread in depth. So if we were to redesign this part, I would have made these threaded holes shallower. We don't need 8 millimeters of thread. It's typically not gaining any strength, and it may allow you to put a thread in that might be partially stripped and still use it, but there's no advantage of having screws this long. So for 2.5 diameters, it would be a 5 millimeter length screw, and so once you get above that, you're not gaining much by having the screw longer. The bolt head will break before the threads will shear off. And so this seems a little excessive for this application, but I want to go extra a little bit deeper, 2 millimeters, and the reason for that is to give enough clearance for the chip of the for the tap when it's coming in. Now we're going to go to the next tab, and our tap drill cycle is going to be deep drilling. This is a perfect application of it. Small diameter, we're going really deep. Alright, so our peck depth is defaulting at 0.015. That's fine. And our minimum peck depth is also at 0.015. So let's just leave that as it is, and we don't need any dwelling, and we'll hit OK. Now our next routine is going to be to tap those same holes. Let's go to drilling. We're going to select the TCOSE library, and we're going to select tool number 10 for the M2 tap, and select OK. And we'll leave it at 500 RPM, that's fine for a small tap. And we'll select our first hole, we'll select same diameter, and we'll go to our heights. We want this to be from model top. We want this from hole top. It's going to go down to 9 millimeters, which is what I modeled. We're not going to go tip through bottom. We want it to stop shy of the bottom. We're going to go to our cycles, and we're going to change this to a right hand tap. I'm going to make sure it's outputting the code to go right handed. Select OK, and we're done. Now we need to profile the outside of the part. I saved this for last because we want the part as rigid as possible up until this point. We're going to go back to the 1/2 inch end mill. So we're going to go 2D contour, and we're going to select the 1/2 inch end mill we've been using before. Okay, we're going to go 4,000 is fine, 40 inches a minute is fine. Actually, let's go 30 inches a minute, 30 inches a minute, 30 inches a minute, 15, and 15. Now we go to geometry. We're going to select the entire bottom of the part. We want to make sure our arrow is on the outside of the part, which it is. And then we're going to go to the next tab, heights. We're going to start at model top, and we're going to go from model top from our machining. And then we're going to cut to the selected contour, but we want to go about a little bit past. So we're going to go -0.02. So that'll give us our bottom height. Will cut a little bit past the bottom here. We're going to go to passes. Okay, we want wear compensation. We do want rough passes, which will allow us to have the finishing step over. I think that's too much. So we're going to put in 0.02 for our finish pass. Okay, our maximum step over is going to be 80% of the diameter of the cutter, which is 0.4. We're going to do one roughing step over, and we're going to minimize all the tabs there, and we are going to do multiple depths. Our maximum roughing depth is going to be 0.125, and we're going to do one finishing step down, and that step down is going to be 0.03. We're going to approach along the wall. We're going to, so this part is 44 inches long. It's a little less than 2 inches. That's a bit long for a 1/2 inch end mill. You could buy one that's got that much flute length, but you lose rigidity. So we want to finish on every step, not just the final. It'll also help us with the fact that we have so much material hanging out of the vise and we're losing rigidity as we go. We are going to use even step downs, and we're not going to leave any stock to leave. We do want the smoothing deviation selected because we want a nice clean surface on the radial part. We're going to move on to linking tab. Skip the first few boxes. We do want a horizontal lead-in radius, and it looks like it's about 10% of the diameter. And we do want a lead-in distance. I'm going to bump that up to 0.1. Just gives us some extra room in case our stock's a little bigger than we anticipate. We don't want a vertical lead-in. It won't serve any purpose. No ramp because we're coming in off the part. And we do want to select our entry position. I'm going to select the entry position as this corner in front so that the operator can see where it's plunging. Is that okay? And we have our multiple passes with our multiple radius lead-ins. Okay, so we've prepped most of the outside surfaces, which can be used for registration for all following operations. Okay, we're done with setup 1. Why don't we simulate this so we can see what we've done so far. Select simulate, turn on the stock, and play. So we're face milling, doing a finish face mill. We're coming in and we're doing the bore in the center. Seems like a lot of steps, but we're kind of coming at that gingerly with that end mill. We don't want to put a ton of side force on this part. Might move it, and then we have disaster. Okay, we're switching to our drilling cycle. Spec drilling. Relative to the diameter of the drill, that's a pretty deep hole. By doing the mini small pecks, we should have fairly straight holes though. Now we have our milling cutter coming around, cutting apart. Now it looks like our simulation is going to experience some collisions here. That's because the end mill we've modeled doesn't have enough stick out, as they say. It's not projecting out of the holder enough in our parameters. So we would need to make sure that we put a note in Fusion in our setup sheet that for the operator to have a minimum of, say, 46 millimeters of projection. The end mill can probably do it. It just needs to be moved in the holder to have a little bit more length. All right, we're done with that operation. Now let's move on to setup 2. In setup 2, we have it orientated like so. And in setup 2, we're pretty much machining this pocket and drilling the holes. Let's do the pocket first. We'll use the same half-inch end mill we just used. So we're going to go to 2D pocket, and we'll leave all our RPMs the same. We're going to go to geometry. We're going to select the pocket area. We're going to set our heights. Our heights are going to be based off model numbers because we've already machined off the stock in the area we're machining. And we're going to machine down to the stock contour, which is fine. Now we're going to go to heights. I think we should do finishing passes. We'll do that at 0.02 step over. We're going to do multiple depths. 0.04 is fine for our step down. We're going to do one finishing step, and we're going to leave 0.01 for that step. We're going to finish at final depth, and we're going to use even step downs. I'm going to hide all this stuff. We're not going to leave any stock to leave. We'll go ahead and select smoothing. I don't know if it's necessary for this. And we'll move on to the linking tab. We'll leave these horizontal lead-ins and linear distances alone. We're going to take out the vertical. Okay, our ramp type is going to be plunge outside of stock, and we'll see what we get here. Okay, so it should be calculating to plunge outside of the stock and feed back and forth until it's milled out this rectangular section here. Okay, we're done with that. Now let's drill these holes. Okay, so we're going to go to drill, and we're going to select the TCOSE library, and we're going to select tool number 20 for the 3mm drill, and then select OK. We have 3mm, and we're at 6,000 RPM with 8 inches a minute of travel. Let's go to geometry. We're going to select one of the holes, and we're going to select all of them at the same diameter. Now you notice these are at different depths, and we're going to need to handle them differently because of that. We're going to make these in order by depth. So it's going to put them in the order by depth. So I think it's going to drill the longest one first. And we're optimizing the order. And we're going to move on to the next tab. So our top height is going to be based off model top for retract. For the top height for the actual cut, we wanted it to hole top because it's going to be based off the individual holes. The bottom height we want based off bottom height, which is the same thing. We want it based off the depth of the specific hole in the model. We aren't breaking through right now, so we want to go drill tip through bottom. That makes sure that the drill tip goes all the way through the hole. And now we want to extend that some more to make sure we clear out any burrs. And in the case of this hole, it's going through the bottom of the hole, but we don't really have that counter bore machined yet, so it won't poke through the bottom of the material. So let's go through and let's go a little deeper by 0.02. So that's 20 thousandths. That'll ensure the shoulder goes all the way through. And we're going to end up with this poking out. It might just create a dimple because it's aluminum. Now we want to make sure that whatever we're supporting the part with, the parallel or whatever, isn't going to get hit by that. Okay, now let's go to our cycle, and we definitely want the deep drill cycle. And yeah, 30 thou pec is fine. I'm just going to round it off, and we can leave the rest of these at default. Let's hit OK. Alright, so we've now drilled those holes. We need to machine off this big block of material on the end. So that's still sticking off the end of our vise. So to do that, we're going to use the 1/2 inch end mill again. Now, so let's go and do that. So we're going to do 2D contour, and we're going to select the 1/2 inch end mill. Okay, 4,000. Let's go 30 cutting. Oh, we can go. Yeah, let's go 30 cutting feed rate. 30, 30, 15, and 15. For geometry, we're going to hold down the Alt key, and we're going to select just the radius. Now notice it's on the wrong side, so we want to select on the outside of our model. And we're going to add a tangential extension. This is going to extend the length at which what we're cutting on that line. And we're going to set that at 0.04 because we have extra material as well. I'm sorry, 0.4. So that's about 80% of the cutter. Then we'll move on to heights. We're gonna start at stock top because remember we got stock still out here on the end, and then we want our top height at stock top, and our bottom height will be the selected contour, and we're going to go past by negative 0.02 to make sure that we clean up the bottom. Now we go to the passes tab, and we're going to leave that at 4/10 tolerance. We're going to change this to wear compensation, and then we're going to move down to roughing passes. We're going to select that box and then come back up and set the roughing step over at 0.02. And then on roughing passes, our maximum step over is going to be 0.4. And then we're going to do one roughing step over and a single finishing step over. Okay, we're going to minimize passes, select multiple depths. And our maximum roughing step down, we're going to do the same thing. It's going to be 0.125 like we did before with one finishing step down, and we're going to leave 0.02 for our finishing cut, so 20 thousandths. Moving down, we're going to finish at final depth because we should have enough flute length. We're going to rough the final. We're going to use even step downs. The rest of these are irrelevant. And then we're going to select smoothing. We'll move on to the linking tab, which is our last tab. We're going to leave all this at default above this line. We're going to have a horizontal lead-in radius of 50 thousandths, which is fine. Our sweep angle is going to be 0. And actually we're going to set our horizontal lead-in radius is 0. We're going to have a lead-in sweep angle of 0, which means it's going to come in the same angle as our cut. And our linear lead-in distance, we're going to bump this up to 0.04. I'm sorry, 0.4, because we want to make sure that we're leading in off the stock. Okay, no vertical lead-in radius. We want to lead in and lead out that are the same. No ramp, and we shouldn't have to pick the entry position. There's only one place to enter. So let's hit OK. And we've now just finished off cutting off the excess material that's remaining on this part. All right, that's it for setup 2. Okay, now we will simulate setup 2 so we can see what we've done so far. Pick on simulate, make sure the stock is selected, and we'll hit play. So the 1/2 inch end mill is going to come in and cut the notch. And we're going to come in and drill the deepest hole, which goes nearly through the part. And it's going to come and cut the other 3mm holes that intersect the bore for the pistons. And it's going to come and cut off the extra stock that we had left that was originally holding the part. Now you notice there's going to be a little bit of material left in the simulation, but that material really wasn't all there because we had profiled around the finished part somewhere around the last couple passes. That block of material on the right hand side would break free and fall off and leave this finished. Okay, we're now ready to move on to operation 3. Select your setup, operation 3, and orientate the block the way it would be in the machine, which would be like so. Alright, now some of the operations we did in setup 1, we can just copy and reapply the tool path to the geometry in this setup, in this orientation, and not have to redo the work we've done. So we used tool number 4 to machine out the bore, and then we did our drilling and our tapping. Those are all operations that need to be done in operation 3. So let's highlight all 3 of those operations, and you can use right click, or you can use the keyboard command Control C to copy and come down to setup 3 and either right click or Control V to paste. We open it up and we've got our 3 operations. We have our warning that we need to generate again. We're going to select the first one and go edit, and we need to reselect the geometry. We're going to leave everything else the same. So instead of having this hole selected, we're going to deselect the geometry and select this hole and hit OK. We're done. We'll move on to the deep drilling, which is the tap drill for the M2. We're going to go edit, and we're going to deselect the face we had, and we're going to select one of the holes on this side. And because we had same diameter already selected, it's going to catch them all. We'll hit OK. Now we'll move on to the next one. We're going to right click on the tool for the tap. We're going to say edit. We're going to deselect the face we had originally, and we're going to select on the hole here and hit OK. All the parameters are already set. That's all we have to do for setup 3. That was pretty easy. So let's simulate setup 3. Okay, pick on the simulate tab. It should simulate the stock looking like this, and we will go ahead and hit play. So it should look a lot like operation 1. Then we come back and do our deep drilling for the tap drills. And now we're going to tap the holes. Alright, now we'll move on to setup 4. Okay, we're going to reorientate the part so that it's as of setup 4. So let's highlight setup 4, and we want X pointing to the right, Y pointing away from us, and Z pointing straight up. Now in reality, not all this stock is here. There's just what we're machining is this little counterbore here. It's a single operation. Let's measure what size that counterbore is. And it is, if we go to secondary units, millimeter. Our diameter is 5 millimeters or 0.197. I believe we can go in with an 1/8 inch end mill and cut this feature. So let's do that. Now once we cut part of the way through, this hole will become visible. We might have a little bit of a hole sticking through from the drill bit, but it's going to clean that up. Okay, so for setup 4, it's just one operation. We're going to do NC, we're going to do 2D, we're going to do 2D contour. We're going to select the TCOSE library, and then we're going to select tool number 17, which is the 1/8 inch flat end mill. And select OK. We're going to leave our spindle speed at 5,000, and we can just leave the feed rates at default. We'll go to geometry. We're going to select the circular counterbore. We want to make sure the arrow's on the inside of the circle, which it is. We're going to go to heights. Our retract height is going to be based off model top. All the stock is gone now. Our top height is going to be model top because all the stock's gone. And we're going to machine down to the selected contour. We're going to go to heights. Passes. We're going to go compensation type wear. We're going to skip on down to roughing passes. And then we're going to come back up and set our finishing step over at 0.01. We're going to come down back to the roughing steps, and we're going to set the roughing step over at 0.1. Smoothing deviation stays at default. We'll move on to multiple depths. We're going to do a maximum step down of 40 thousandths is fine. We'll do one finishing step down, and we'll also leave 0.01 of an inch or 10,000ths of an inch for that. We're only going to finish at final depth. We'll rough the final. We use even step downs. We're probably only going to get one anyway. We don't need a stock to leave, and we should have smoothing on because we want a nice round circle. We go to our linking tab, leave these all at default. Lead-in radius, we may not even get one, so let's go to 0.01. No, let's leave it at default. Linear lead-in at 0.01, and no vertical lead-in. And let's select OK. So we've got a real small cuts there. Okay, so we are done with this part. We can simulate this. Goes down and does our little counterbore. Okay. So that's it. That's your first 4 setup part. You are going to need to run programs and setup sheets for each of these setups. You should have 4 discrete programs, 4 discrete setup sheets. All the setup sheets should show the part in the orientation that that operation is going to be set up in. Otherwise, the person setting this up is not going to have any clue of how much stock's there or where the orientation of anything is. Okay, and that ends the video for the TCOSE-08 part, and we'll catch you on the next one.